Good day everyone. The topic of this video is about free fall motion. You can already have a general idea what is free fall motion from the words presented in front of you. Am I right? Or am I right? Well, we will find out the answer of that question in our discussion. Aristotle speculated that heavy objects fall faster than the lighter ones. The Greek philosopher Aristotle said that heavy objects seek their natural place faster than light ones, that heavy objects fall faster. Galileo Galilei challenged the idea using two cannonballs of different sizes. He tried dropping them simultaneously off of the Leaning Tower of Pisa and found out that they fell at exactly the same rate, that is negative 9.8 meters per second squared. According to legend, Galileo dropped weights off of the Leaning Tower of Pisa, showing that gravity causes objects of different masses to fall with the same acceleration. In recent years, researchers have taken to replicating this test in a way that the Italian scientists probably never envisioned, by dropping atoms. This constant value has since then been established as an object's acceleration due to gravity on the Earth's surface. Constant means fixed, something unchanging. In this lesson, you will explore the mathematical significance of this value and its relationships to other. What happens to an object's velocity as it undergoes free fall motion? What do you think would happen? Let's see. Use the fact that the magnitude of acceleration due to gravity on the Earth's surface is nearly constant at approximately 9.8 meters per second squared in free fall problems. Solve problems involving one-dimensional motion with constant acceleration in contexts such as free fall problems. One-dimensional or one dimension implies motion along a straight line or a single direction. Apply the four major kinematic equations of uniformly accelerated linear motion to free fall. Calculate unknown quantities in problems that involve free fall motion. So we will get to know these four major kinematic equations in the next slides. Galileo was able to establish the mathematical relationship between distance and time. For any object that has fallen from rest, the distance that it will cover will be proportional to the square of the time it has taken to fall. So distance is related to time. All objects on the Earth's surface will fall with equal and constant acceleration in the absence of air and other forms of resistance. So all objects in the Earth will fall with the same acceleration if there was no air or hindrances. This acceleration is termed as acceleration due to gravity, or g, on the Earth's surface, and its approximated magnitude is equivalent to negative 9.8 meters per second squared. So acceleration is termed as acceleration due to gravity and has a approximated magnitude that is equivalent to negative 9.8 meters per second squared. Also, its symbols are a subscript y or g. A freely falling object has an acceleration of negative 9.8 meters per second squared, the negative value of which signifies that the acceleration is downward. So it indicates that an object that is falling has an acceleration of negative 9.8 meters per second squared. And from the word falling, the direction of falling is downward, right? So its value is negative. Just like the picture being shown, downward. The initial velocity of any object thrown from an elevated height is 0 meters per second. So the initial velocity is 0 meters per second. Why? Because velocity is the directional speed of an object in motion that indicates its rate of change in position. And since initial means placed at the beginning, so there's no change in position. So if there's no change, so it's 0. That's why it's 0 meters per second for there's no change in position. For an object thrown vertically upward, it is expected to slow down while going upward and attain a velocity of 0 meter per second at the peak of its motion. So why is an object thrown vertically upward slows down? Because it's against the gravity. So it will decelerate or slow down. The magnitude of its velocity when thrown up is equal but opposite in sign to its velocity when it goes back to the same height. So why are they opposite in sign? From the word thrown up. Its direction is upward, and I state in the previous slide that it's negative if it's downward. And the opposite of downward is upward, and the opposite of negative is positive. So that's why it's equal but opposite in sign. As you can see in the image being shown, the symbol of acceleration to gravity are A subscript y or g, and its SI unit is negative 9.8 meter per second squared constant. Velocity. The symbol of velocity is v, and if v subscript 0 y, it's the initial velocity. And if v subscript y, it's the final velocity. And the SI unit of velocity is meter per second. Position. The symbol of position is y. And if y subscript 0, it's the initial position. And if y, only y, it's the final position. And the SI unit of position is meter. Time. There's no symbol being shown in time, so let's just ignore it. So the SI unit of time is second. The value of g is said to be a mere approximation, since it varies according to the altitudes on the Earth's surface. The difference, however, is significantly small that they can, under most circumstances, be ignored. The value of g is said to be a mere approximation. Approximation means not exact, since it varies according to the altitudes on the Earth's surface. Altitude means the height of an object. So it's said that the value of g is said to be a mere approximation, not exact, since it's relying to the height of the object. But the differences is not noticeable. It could be ignored. For example, we have the differences between decimals. Let's say we have 9.4 and 9.3. If we round it off, the answer is still 9, right? And sometimes we ignore the decimal if the answer is still the same. So that's my point. The differences is significantly small that it could be ignored. Let me introduce to you the four kinematic equations. The first one is velocity-time equation. Its formula is final velocity equals initial velocity plus acceleration times time. Second one is position-time equation. It has a two formula. The first one is final position equals initial position plus initial velocity times time plus 1/2 times acceleration times time squared. The second one is final position minus initial position equals final velocity plus initial velocity over 2 times time. And the last one is velocity position equation. Its formula is final velocity squared equals initial velocity squared plus 2 times acceleration times final position minus initial position. The initial velocity of any object thrown from an elevated height is 0 meter per second. So the initial velocity is 0 meter per second. Why? Because velocity is the directional speed of an object in motion that indicates its rate of change in position. And since initial means placed at the beginning, so there's no change in position. So if there's no change, so it's 0. That's why it's 0 meter per second, for there's no change in position. Let me give you an example. If a 10 kilogram block is dropped from rest, determine the distance it will have covered after 2 seconds. The distance the block will have covered after 2 seconds is 19.6 meters. The negative value implies that the motion is downward, so it has already an answer, which is negative 19.6 meter. So what we will going to do is to determine what equation we will going to use in order to find this answer. Keep in mind that each one of the kinematic equations contain 4 variables. If the value of 3 variables are known, then the fourth can be calculated, which is the one we will going to solve. So the first step we will do is to find the 3 known variables. In the first line of sentence, we can already determine the first known variable, which is dropped from rest, which means the initial velocity. And since it's the initial velocity, the value of it is 0 meter per second. So we already have the first known variable. Wait, let me write it first. Initial velocity. Wait. Initial velocity. So we already have the first known variable. The second one is dropped. Acceleration. No. So the second one is acceleration. From the word dropped, it fall. And we already have the value of acceleration, right, in the previous slides, which is negative 9.8 meter per second squared. So we already have the second known variable. Now the third known variable is time, which is 2 seconds. You can already saw it. So and the fourth variable is the distance, the unknown variable. Since we will find the unknown variable, what the fudge, no, mali. And the fourth variable, which is the unknown variable, is the distance, since we will going to determine the distance. Now, we already have our 4 variables. So the next step we will going to do is to find what equation we will going to use. So first, velocity time equation. Well, it has a final velocity equals initial velocity plus acceleration times time. We have the final velocity and which is the position time equation. This, since it has a initial velocity, acceleration, and time fit for our variables. Let me just use this space, since in the other slide I don't have enough space and it's kind of lisod ko og suwat dito. So I'm gonna use this since nanadiri ang equation, then ang lang sa ako mag gamiton na ako ni. So let's wrote our variables. First one, we have the initial velocity, right, which is 0 meter. So big. Initial velocity 0 meter per second, and the acceleration is 9.8 meter per second squared. And the what's the other one again? Time, which is 2 seconds, and distance, which is the unknown. That's a question mark. Sorry, I don't have like this the pen of 4 phones. Sorry, I'm just using my thumb, my finger and index finger to be exact. Anyways, so yes, so that's our 4 variables. So let's apply it. So let's substitute it in the equation. So since we don't have initial position, so let's just cross it out. And since the initial velocity is 0 meter per second, so it's not necessary to put it since it's already 0, right? So cross it out. So the only formula left is this. So we were going to use this one. So let me erase it first for more space. Just memorize the values. So this formula, right? So let's apply it. So copy the 1/2 and g, which is acceleration. So and our acceleration is times negative 9.8 meter per second squared, and then time is 2 seconds, right? 2 seconds squared. You can write this on your paper for better access. Sorry, I'm poor. Yes. Anyways, so if we solve this problem, we will going to have the negative 19.6 meter by why man, cause so that's our answer. So this is our solution, and we were able to get the negative 19.6 meters, which is this negative value, negative 19.6 meter. Now, my fellow classmate, groupmate, Geraldine would be giving another example for you to understand it more clearly. Let's have a brief summary. Freefall refers to an object's motion under the sole influence of gravity. All objects on the Earth's surface will fall with equal and constant acceleration in the absence of air and other forms of resistance. All objects in the Earth that will fall would have equal acceleration if there was no air or other hindrances. The acceleration due to gravity, or g, on the Earth's surface has an approximated magnitude equivalent to negative 9.8 meter per second squared. So the acceleration due to gravity has an approximated magnitude equivalent to negative 9.8 meter per second squared. So that's the end of our discussion. I hope you learned something in this video and hope you were able to understand our explanations. Bye.